We now discuss the solution of a problem from the section Trigonometry. And this question has appeared in Joint Entrance Examination Main held on 27th July 2021 in the second shift. The problem is, let f be a function from the set of real numbers to the set of real numbers. It is defined as f of x plus y plus f of x minus y is equal to 2 times f of x into f of y, and f of 1 by 2 is equal to minus 1. Then the value of sigma k is equal to 1 to 20, 1 by sin k into sin of k plus f of k is equal to. We are given 4 options. So these are the 4 options what are given to us. And f is a function from the set of real numbers to itself, defined as this way: f of x plus y plus f of x minus y is equal to 2 times f of x into f of y, and the value of f at 1 by 2 is minus 1. Then we have to find the value of the finite series. The value of the finite series, sigma k is equal to 1 to 20, 1 by sin k into sin of k plus f of k. These 2 terms are there in the denominator, and this finite series sum is equal to. These are the 4 options given to us. We now discuss the solution of the problem in detail. We are given a function from R into itself, defined as f of x plus y is equal to f of x minus y is equal to 2 times f of x into f of y. Call this as the equation 1. This equation 1 is a functional equation. And now by looking at this equation, what I remember or recall is that's this cos function, cos of x plus y plus cos of x minus y. When added, you get 2 times cos x cos y. So that gives me a lead. So therefore, what I will say is, let f of x is equal to cos of ax. Then let's see whether this is going to satisfy this equation or not. We will see. F of x plus y plus f of x minus y is equal to cos of a into x plus y plus cos of a into x minus y. And now when added, you use the formula cos c plus cos d is equal to 2 cos c plus d by 2 into cos c minus d by 2. So that will be 2 cos a c plus d, a into x plus y plus a into x minus y whole by 2 cos of the difference a into x plus y minus a into x minus y by 2. Now ay cancels here, and here ax cancels, and you will get ultimately 2 cos ax into cos ay, and that will be 2 times f of x into f of y. So this says cos of ax works as a solution for this functional equation. So f of x is equal to cos of ax satisfies this functional equation 1. Therefore, f of x is equal to cos ax is a solution of 1. Here we have verified that this is a solution, but we have not solved this equation as it is, and there may be several There may be other functions satisfying this one, but for our need, this is a solution for that. And solving the whole of this functional equation is a different aspect of study. We are not interested in that. We are interested only in this much only. And now we have here that f, that functional equation is here, and f of 1 by 2 is equal to minus 1. This is the given one. So we have already seen f of x is equal to cos ax is a solution of this functional equation. So now f of 1 by 2 is minus 1. That condition we will put. F of 1 by 2 is equal to minus 1, and that is cos of x is 1 by 2, cos of a by 2 is minus 1, and that will imply a by 2 is this cos pi will be minus 1, therefore a by 2 is pi, that will imply a is equal to 2 pi. Therefore, f of x is equal to cos of 2 pi x. A is 2 pi x. Notice now, for a natural number k, f of k will be cos of 2k pi. Cos of 2k pi is multiples of 2 pi. Cos of 2 pi is 1. So, multiples of 2k pi is also, multiples of 2 pi is also 1. So, cos of 2k pi is 1 for any natural number k belongs to n. Now, sigma k is equal to 1 to 20. That means k is a natural number, range varying from 1 to 20 of 1 by sin k into sin of k plus f of k. So for k is running 1 to 20, k is a natural number, then what will be f of k? F of k is 1. So this will be 1 by sin k into sin of k plus 1, because f of k is 1. Now by looking at this one, now the idea what we get is, in the numerator, sin of k plus 1 minus sin k, if you write sin of k plus 1 minus k, if you write, but what is sin of k plus 1 minus k? K cancel sin 1. So you multiplied by sin 1, so you divide by sin 1. So this is the one. Now expand this sin of a minus b formula, put it and expand it. 1 by sin 1, sigma k is equal to 1 to 20, sin k plus 1 cos k minus cos k plus 1 into sin k by the denominator. Now what we do is separate them. This first term by the denominator minus the second term by the denominator. So in this one, sin k plus 1 cancels, and sin k cancels in the second term. So what is left is 1 by sin 1, sigma k is equal to 1 to 20, cos k by sin k minus cos k plus 1 by sin k plus 1 is the one what is left out. Now the sigma what we have to consider still. So we will do it in the next slide. That is what we have. Now cos k by sin k is cot k, cos k plus 1 by sin k plus 1 is cot k plus 1. So write down 1 by sin 1, sigma k is equal to 1 to 20, cot k minus cot k plus 1. Now if you see this is a finite series with finite number of terms, and this is a telescopic series. In the telescopic series, if you expand, the terms will get cancelled, and you will be left with the first term minus the last term. So let's see what it is. 1 by sin 1 into expand. For k is equal to 1, cot 1 minus cot 2. K is equal to 2, cot 2 minus cot 3. K is equal to 3, cot 3 minus cot 4, right? Plus so on and so forth. 19, k is equal to 19, last but one term, cot 19 minus cot 20. And the last term, k is equal to 20, cot 20 minus cot 21. Now observe, cot 2 cancels, minus cot 3 cancels, minus cot 4, somewhere cot 4 cancels, cot 19 before term it cancels, minus cot 20. Cot 20 cancels and you're left with first term cot 1 minus the last term cot 21. So 1 by sine 1 into cot 1 minus cot 21. That will be equal to 1 by sine 1. And look at your options. They are in terms of cosecant 1 square, something like that. So 1 by sine 1 into cot 1 is cos 1 by sine 1 minus cos 21 by sine 21. Take the LCM. And that will be 1 by sine 1 into cos 1 into sine 21 minus cos 21 into sine 1. And this is sine 21 into cos 1 minus cos 21 into sine 1. And if you see carefully, it is sine of a minus b, that is sine of 21 minus 1 by the denominator. And that will be 1 by sine 1 into sine of 21 minus 1 by sine 1 into sine 21. And sine of 21 minus 1 is sine 20. Sine 20. And 1 by sine 1, sine 1. So sine square 1. 1 by sine square 1 is cosecant square 1. And 1 by sine 21 is cosecant 21. And this is the sine 20. So the cosecant square 1, cosecant 21 into sine 20. Let's look at the options. In these options, our answer cosecant square 1 into cosecant 21 sine 20 appears against the option 2. Therefore, our answer is option 2. So that is the discussion of the solution of a problem, and it is a very important, very interesting problem and a very important problem. I am sure that you have understood the solution of this problem, and questions of this nature, or sometimes will be difficult, unless you have some practice beforehand. Anyway, I wish you all the best. Thank you.